Hello everyone. In this video, we are going to practice some questions of binary search. I am going to take up two questions. The first two, that is the search insert position and capacity to ship packages within DSA. And you will get comfortable with the things I discussed in last classes. So let's start with the first one, search insert position. So you can pause the video once and read the question so that you can get to understand like what is written. In this question, we need to find out the element like 1356 is the given array. So if the target element is 5, we need to find if that element is present in that array or not. For example, 5 is present. So we need to simply return the index of that element. And if 5 was not present, so we need to return the index of the element at which the 5 would get inserted if we try to insert 5. I hope the question is clear. If the array is 1357 and if your target element is 5, so 5 wants to get inserted in this array. But the problem is that 5 is already present in that array. So it will simply return the index at which it is present, for example, 2. Now let's suppose the target element was 4. So what 4 will want? 4 will want to get inserted in this array and it will check that yeah, I am not present, I can get inserted. So at which position will you insert 4? You will definitely insert 4 at the index 2, right? Because after 3, 4 will come, right? So what will be the index of this position? It will be 2. So you need to return the index. I hope the question is clear. So like I discussed some important functions. In that I discussed lower bound. So in this question, what I will do is, first of all, I will write the entire code of binary search. Do all those stuffs like we will be initializing starting and ending index. Then we will be searching. We will be shifting our starting and ending index, calculating the mid, and those all. And then we will solve this question. But after doing that, I will be solving this question in just one line by using the function called lower bound. And by that, you will like learn the importance of load. So let's code it up once. Like if you see the concept, what we can use is, let's suppose this is the array. Our answer will definitely lie in the starting index and ending index. Now let's suppose our target element is greater than the element present at this last position. So what will be the position at which this target element will get inserted? It will be n, right? Now let's suppose this is not the case. Let's suppose our target element, we find out some mid value and we can say, and we got that this mid value is equal to the target element. If that is the case, we can simply return this mid value. If this is not the case, what we can do is we can keep an answer. If this mid value is greater than the target, like in this case, if the target element was 4 and let's suppose the mid comes out to be 5, the mid value comes out to be 5. So we can see that the mid value is greater than the target. So yes, that can be the position at which we are going to insert the target element. That can be the position. For example, for array 1357, if the mid value comes out to be 5 and you want to insert 4, then 5 may be the position where you are going to insert 4. So what you will do is you will substitute your answer as this mid value and look in the rest part of the array. Like you will do ending index as mid minus 1. You will search in the left part of the array if the better answer exists. What if the element which you encountered is less than the target element? For example, suppose the mid value was 3. If mid value is 3 and you want to insert 4, then you know that you are not going to insert 4 at this position. 4 will be inserted anywhere at the right of 3, right? So what you are going to do here is you are going to shift your starting index to mid plus 1, right? So yeah, we are going to code it down. Let's check the code once. We know that the code is, the question is here. We can like find out the size of this vector. We can initialize our starting index with 0 and ending index with n minus 1. We can keep an answer. Now let's suppose the element present at the end is less than the target element. Then in that case, we simply know that we will insert the target element at the end position. So we will simply return n over here. But if this is not the case, so we will like write binary search over here. We will find out the mid position, which will be starting index plus ending index minus starting index by 2. And we will check like if we found the element, if nums of mid is equals target. So we know, yeah, this is the position. We are not going to insert that element, target element is already present. So we will return mid over here. If this is not the case, we will check if nums of mid is less than the target. So we know that we are not going to insert our target element as this position, and we will simply shift our starting index to mid plus 1. Otherwise, if nums of mid is greater than target, so we know that, yeah, this can be the position where we are going to insert our target element. So yeah, that is a possible answer, and we will look for a better answer in the left part of the array. So we will shift our ending index. And in the end, we are going to return answer. Let's check this one. If it's working or not. Okay, so we got a compilation error over here. If ending index will be equals. Okay, so this got accepted, right? So yeah, this all stuffs we are going to do. But now, if you look at the definition of lower bound, what does lower bound give us? Lower bound give us the address of the element which is less than the smallest element which is greater than or equals to that element, right? For example, in this array, if you find out the lower bound of 4, what you will get? You will get the address of 5, right? Similarly, if array was something like this, and if you find out the lower bound of 4, so you will get the address of 4. So you can simply you can simply apply the lower bound with target element as target, and you can find out the index. Because this is what lower bound does for us, right? Lower bound वही करता है ना अपने लिए जो इस क्वेश्चन में निकालने बोला है. लोअर बाउंड क्या करता है? वही करता है. ये सिंपली लोअर बाउंड का डेफिनेशन बोल दिया इस क्वेश्चन में. So if we apply the lower bound, let's like it will be a one line code. So we are going to return lower bound num dot begin. Oh, sorry. Wait, I missed it. Nums dot end. The target element is this, and for the this returns the address of that index, and we simply want the index like this returns the address. So for finding the index, we will simply subtract it with the first element. So yeah, this will work. This works. Okay, so this is working fine. So yeah, you can say that this function is of great importance. This is not only in this case. There will be like questions where you need to code up too much, and using lower bound, you can reduce the binary search part to a one line code. So yeah, this function is of great importance. So let's move on to the next question. Capacity to ship packages within D days. So you can like pause the video once and try to read the question. Okay. So let's see what the question tells us. In the question we are given array weights where we are given some weights like W1, W2 up to some Wn. Now what we need to do is we need to ship this all packages to some location. Okay. And we have only D days in our hand. पूरा उम्र नहीं है ट्रांसफर करने के लिए, खाली डी डेज है। डी डेज में काम खत्म करना है। डी डेज से एक दिन भी एक्स्ट्रा लगा तो पैसा नहीं मिलेगा, तो डी डेज में काम करना है अपने को, है ना। सो या डी डेज में काम करना है। बट द प्रॉब्लम इज लाइक यू हैव अ मशीन, लेट्स से यू हैव अ मशीन। अब हमें अगर डी डेज में काम करना था तो हम क्या बोलते हैं कि हम एक दिन में ही काम कर सकते हैं। वी कैन डू द वर्क इन वन डे ऑल्सो, लाइक इफ वी ट्रांसफर ऑल द पैकेजेस इन अ सिंगल डे। If we do that, we can transfer all the packages in one day, right? So D days अगर D5 भी है, so we are doing the work early only. But ऐसा नहीं कि उसके लिए extra payment मिलेगा. The payment will remain the same. But if you do that, what you are doing is you are putting load on your machine, right? If you are transferring all the packages in one day, your machine needs to transfer, right? You are not like carrying that and transferring. Your machine is transferring. Now your machine has a wish. Your machine has a wish that it should transfer the minimum packages. Like अगर 15 पैकेज ट्रांसफर करके तुम्हारा डी डेज में काम हो जा रहा है और 14 पैकेजेस पर डे ट्रांसफर करके भी डी डेज में काम हो जा रहा है, so the machine will prefer the 14th one because it wants to ship the minimum packages possible. So आपको समझना होगा कि ये बाइनरी सर्च इसमें कहां से आया, like how come we get the binary search over here. See, if you are transferring one package per day, so you will require some amount of like days. If you try, and let's suppose the amount of days required over is X. If you transfer two packages per day, just tell me like the amount of days taken to transfer the packages which will either be less than or equals to X. Can I say that? अगर एक पैकेज को आप एक दिन में ट्रांसफर कर रहे हो, आपको एक्स डेज लगा। अब आप पर डे दो पैकेज करके ट्रांसफर कर रहे हो, सो उससे कम ही टाइम लगने वाला है ना, एक्स से तो कम ही लगेगा या इक्वल लगेगा। Similarly, if you transfer, let's suppose some K packages per day, you will you will finish your work in, let's suppose, D dash days. And if you transfer K plus 1 packages per day, your work gets completed in D days. And this goes on continuing. So if you're transferring like let's suppose X was greater than D, आप D days में आपको काम खत्म करना है, but the number of days taken over here is greater than D. So number of days, once you increase the number of packets transfer per day, the number of days increases, right? The number of days decreases. At some point of time, you will get that the number of days required is actually less than or equals to D. So at that point of time, you will say that, okay, I am going to transfer this much amounts of packet. So यहाँ देखो तो precedented binary search जैसा केस हो गया ना, कि once you were transferring one packet, the condition was false. Like the number of days taken was greater than D. Similarly, for 2, the condition was false. Similarly, the condition was false for some packets, but you got, when you transferred certain amount of packets per day, you got the condition as true. Like you were able to transfer all the packets within D days. And once you increase the number of packets, it will always come true, right? क्योंकि days या तो कम या equal लगेगा। ऐसा तो नहीं कि आप एक दिन में ज्यादा पैकेज ट्रांसफर कर रहे हो और आपको और ज्यादा दिन लग रहा है ट्रांसफर करने में। दैट इज नॉट द केस। सो यू विल गेट ट्रू फ्रॉम हियर। सो इन दिस क्वेश्चन यू नीड टू फाइंड आउट द मिनिमम पैकेट्स सच दैट यू गेट द वर्क डन विद इन डी डेज। ये सब में आपको डी डेज में काम खत्म हो रहा है, बट मिनिमम पैकेट्स किसके लिए लग रहा है? इसके लिए मिनिमम पैकेट्स लग रहा है। सो यू नीड टू फाइंड आउट द वैल्यू ऑफ दिस पोजिशन। आई होप द क्वेश्चन इज क्लियर. Like the approach is clear. You need to find out this because once we move from left to right, we are increasing the packets and decreasing the days, right? हम पैकेट जैसे जैसे बढ़ा रहे हैं पर डे, तो उससे हम लोग का डेज तो कम ही होना है ना. तो at some point of time you will get that the number of days taken to transfer, like when you were transferring certain amount of packets, the number of days taken to transfer all the packets was less than equals to the maximum amount of days you can take. So yeah, that is the condition. Now one more thing in this question is, like, if you are transferring this like this packet, like this weight, let me see what they have given, like a packet of certain weight. This is a single packet of certain weight. Now if you are transferring this packet, you will transfer the entire packet, right? आप पैकेट को काट के तो ट्रांसफर नहीं कर रहे, आपको entire packet ट्रांसफर करना पड़ेगा. So yeah, this thing you need to keep in mind. So how we will initialize our starting and ending index? We are getting the condition like this. Okay, false, 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 true, true, true. So we will, the starting index is the minimum permissible value. Now tell me the minimum permissible value, the minimum weight which you need to transfer. Like अगर एक किसी भी पैकेट का वेट अगर 10 है और सारे पैकेट्स का वेट इससे कम ही है, तो आपको मिनिमम वेट 10 तो रखना पड़ेगा, तभी आप इस पैकेट को ट्रांसफर कर पाओगे. अदरवाइज आप ये पैकेट को तो कभी ट्रांसफर नहीं कर पाओगे ना. Like there are, let's suppose 1, 2, 5, 7, 3, 9, 10. These are the weights and you are transferring those. Now if you can transfer 10 packets, like you can transfer like 10 kg, let's suppose the weights are in kg. So if you are able to transfer only 7 kg per day, so never you would be able to transfer the this packet with 10 kg, right? क्योंकि आप पैकेट को आधा करके ट्रांसफर नहीं कर सकते, आपको पैकेट को पूरा ही ट्रांसफर करना पड़ेगा. So therefore we can say that the minimum permissible value is the maximum element of the array. Minimum permissible value is the maximum element of the array. And what is the maximum permissible value? Like कुछ भी ट्रांसफर कर लो आप, पूरे के पूरे वेट्स एक बार में ट्रांसफर कर लो, कुछ भी ले लो. लाइक इसका सम अगर आप ले लेते हो ये सारे वेट्स का, अगर आप उसको एक बार में ही ट्रांसफर कर दिए तो मिनिमम 1 डे तो लगना ही था, तो एक ही डे लगेगा. सो यू कैन से दैट सम ऑफ द एरे, सम ऑफ ऑल द एलिमेंट्स ऑफ एरे. So this is the maximum permissible value. Now let me discuss a template with you for binaries, for questions of binary search. Now this is one of the most important template and you can use it in any type of question. Like when I say it, I mean it. Like any type of question you can use it. You will initialize your starting index with minimum permissible value. You will initialize your ending index with maximum possible value, and you will keep an answer initialized to -1. Now what you will do is you will run a while loop and you will put starting index less than equals to ending index. Like many get confused, we need to write less than equals to or only less than. How to shift the starting index को mid करें कि mid +1 करें. Similarly ending index को mid करें कि mid -1 करें. ये सारे आपके जो डाउट्स हैं वो इस टेम्पलेट के साथ क्लियर हो जाएंगे. Like once you start using this template, you don't need to worry about these all things. So you will write while starting index less than equals to ending index, you will find out your mid, which will be starting index plus ending index minus starting index by 2. And you will check for the condition. Like let's suppose we were doing false. Let's suppose our condition was, we are writing this code for false, 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 true, true, true. Let's suppose this is the the pattern we got and we are writing this code for this. You can simply change it for this also, but I am writing down for this in this present template. So what you will do is, if condition is true, like condition for this mid is true, then you will simply tell, yeah, this is one of the possible answers. So let's keep it in our answer and let's search for a better answer in the left part of the array, right? Because if you come in this position, yeah, this is a possible answer, but you need to search for a better answer, right? Because you need to find out the first true. Otherwise, if the condition was false with that particular value of mid, so you can say, yeah, that is not our answer. So we will simply shift our starting index to mid plus 1. So if you write this one and even after writing this loop, your answer is -1, this says that the answer is not possible. And if your answer gets some value, then you can say, yeah, that is the answer. So this is the most important template for questions of binary search. You can go through it once more and like see. Now, what if the pattern was something like this? What if the pattern was something like this? Like we discussed for this pattern, right? False, 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 true, 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 true. What if the pattern was something like this? So what you will do is you will not change anything. It like depends on your requirement. If you need to find this false, so whenever you encounter the condition as false, you will keep your answer as that mid and do as ending index as mid -1. And whenever you encounter true, you will simply do starting index equals to mid plus 1. This is when you want to find first false. Similarly, if you want to find the like last true, so whenever you get the condition as true, you will keep your answer as mid and do starting index as mid plus 1. And if you encounter false, you will simply do ending index as mid -1. So I hope you are like getting to understand what we are doing over here. So yeah, now let's come back to that question. In this question, what we were getting is we were getting false, 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 true, 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 true. So yeah, let's code it down. We will initialize our starting index with the minimum permissible value, which is nothing but the maximum element in this array. And we are going to initialize with our ending index with the like maximum. What we can do is we can transfer all the weights, all the packets in one day. So that will result, the weight will be nothing but the sum of all the weights, right? So yeah, this is how we will initialize the things. We will keep one answer initialized to -1. This is the same template which I discussed, right? Now we will see like while starting index is less than equals to ending index, we will find out the mid, which will be nothing but starting index plus ending index minus starting index by 2. Now we will check if with that condition of mid, we are getting the value as true. And since we want the last, right? Like we have over here false, 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 true, 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 true. And we need to find this true, right? So once we are finding the true, we need to say, yeah, the answer, this is one of the possible answers. And we will look for a better answer in the left part of the array. And if we are finding false, we can say, yeah, this is not the possible answer. And we will look for the answer in the right part of the array. So now the question comes is what will be the condition? Let's suppose you are transferring D packets per day. Okay. You are transferring D packets. D weight, I must say, D weights you are transferring per day. So let's make a helper function which will say, yeah, you are transferring mid amount of packets per day. You have this weights vector and you need to pass the maximum allowed permissible days. Like maximum you can take this amount of days, right? Now we will see that when this becomes true. These are the maximum like allowed packets you are transferring, and these are the weights and days. Let's suppose the number of days you took till now is 0, and the number of like these are the number of days, and the number of weights you have taken till now is, let's suppose it is 0, right? Now uh, let's take the size of this vector. While and initialize your, you are going to start from beginning while I is less than n. If suppose the number of weight, the weight you took till now plus the weight at this present position is greater than the maximum allowed weight which you can take. If this is the case, what you will do is you need to say, yeah, in this particular day, we can't transfer this present index of I, and we need to take one extra day. We need to initialize our days with 1, right? Like the first day is the one which we are entering with. So we will increase our number of days once we reach this condition. And we will say, yeah, if we are entering a new day, so till now we have transferred 0 packets. So we will again make our temp as 0. And after this, what we will do in the present day in which we are, we will simply add our weights. Like we are taking this amount of weights, and we will simply increment the value of I. Now, at the end of the while loop, if the number of days we took is less than equal to the maximum allowed days, then we will say, yeah, we have fulfilled the condition, so we will be returning true. Otherwise, we will be returning false. So this should work. Let's check this one. Okay, we are getting compilation error. Let's see where. Like, okay, okay. So over here we are getting compilation error, right? Okay, so we have not returned our answer, right? We need to return the answer. Okay, it is running. Let's submit it once. Yeah, this is working fine. So yes, you can say that this is like one of the most important concept of binary search. The questions which you will get in your online assessment, coding round, or interview will be based on this. Like it will be either easier than this or will be based on this. So yeah, you can learn from here. Like this is the most important pattern. If you are able to understand this pattern, and if you can like you can write this template down and keep it somewhere, this template, this is going to work in each and every question. You will shift your answer on the basis of what you want. If you want false, so in case of false you will keep your answer, and if you want true, so in case of true you will keep your answer. So yeah, that's all from this video. Meet you in the next one. Thank you.